And welcome back to another podcast with Mr. Hagan. And on this podcast, we're going to talk about the concept of elasticity in economics. And we are going to focus on the specific, because there's many types of elasticity. We're going to focus on the specific type of elasticity called price elasticity, or sometimes also called demand elasticity. Now let's do some labeling on our graph over here. So obviously this is going to be on the horizontal axis. This is going to be the quantity and of some good, and this is going to be the price of some good. And we already know that when the price of a good goes up, people will buy less of it. Okay, we already knew that concept. That's the concept behind the demand curve. But now what we want to do is we want to say, when the price goes up, how much less will the consumer buy? How much less of the good how will they buy as a result of the higher price? So that's really important to be able to measure this with more accuracy, with real numbers. So it's not enough to just say price goes up, people buy less. We want to say price goes up by this much, quantity goes down by this much. So we want to be able to measure that. And the way we're going to measure that is with our elasticity formula that's up here. So first of all, let's write our symbol for elasticity. So it looks like that. That's a Greek symbol or letter. I don't remember what it is, but this is what represents elasticity for economists. So elasticity is the percent change in the quantity demanded divided by the percent change in the price. That is to say this, how much does quantity change when the price changes? Okay, so again, we're trying now to put a magnitude on this, a number on it. How sensitive is the consumer to changes in price? How much do they change their quantity demanded in response to a change in the price? And then these little triangles, of course, are delta, and they mean change in. So now let's rewrite our formula just a little bit. We can rewrite our formula like this. Percent change in quantity is calculated by taking the change in the quantity divided by the starting quantity. Percent change in price is calculated by taking the change in price divided by the starting price. So let's just go ahead and do the calculation, and then I think you'll see what I mean. So we're going to do the elasticity calculation from when the price increases from $6 to $7. So the price is going to increase from $6 to $7, and we're going to ignore negatives, and we'll see a little bit later why we're going to ignore negatives. It's kind of like we're doing an absolute value calculation. So let's go ahead and do it. So elasticity, let's write out our formula. I'm going to use this right here. So elasticity is the change in the quantity divided by the starting quantity, all divided by the change in the price over the starting price. So that's our formula. And now we just go ahead and plug in numbers. So let's see, when the price goes up from $6 to $7, the quantity demanded by the consumer, this is the number of units, the quantity of units that they want to buy. When the price was $6, they wanted to buy 115 units. When the price went up to $7, they only buy 110 units. So the quantity that the consumer wants to buy decreased by 15. So we're going to put the change in quantity is going to be 15. And notice it's technically negative 15. It went down by 15, but we're ignoring the negatives. So it's just a change in 15 divided by the starting quantity. We started at this point when the price was 6. The starting quantity is 115. So it's 15 divided by 115. That's my percent change in quantity. All divided by the percent change in price. Well, the change in the price was $1. Price went from $6 up to $7. I said that right here. Price went from $6 to $7. So the price went up by $1 divided by the starting price. This was the starting point when the price was $6. And now it becomes a calculator exercise. So I went ahead and punched these in the calculator. 15 divided by 115 is 0.13. All divided by 1 divided by 6, which is 0.16 repeating. So I rounded that to 0.167. And then 0.13 divided by 0.167, and I get an answer of 0.78 or 78 hundredths. Now, it's really important to say that every time that we write our answers for elasticity, we're always going to write it over 1. We're always going to write it over 1, which is a legal move. You can always write anything over 1, and it doesn't change it mathematically. The reason why we care about this in economics is it reminds us that there's 2 parts to this formula. There's the percent change in quantity, which is represented here by the numerator, and then there's the percent change in price, which is represented by the denominator. So the way that we can say this is we can now say that a 1% increase in the price, that's this, a 1% increase in price, causes a 0.78%, that's this, decrease in quantity. Now, you say, well, Hagen, you have decrease here. You didn't write a negative. Yeah, we're ignoring negatives. We just know that on a demand curve, price and quantity always go in the opposite direction. So we don't have to bother writing the negative. We just know that price and quantity always go in the opposite direction. So if price went up, quantity went down. This is in the denominator is my 1% increase in the price, so this must be a 0.78% decrease in the quantity. Now, it's not technically correct what I'm going to write, but let's just say if we thought about this going in the other direction, we might be able to say a 1% decrease in the price causes a 0.78%, and now I would say increase in the quantity. Okay? Now it's not technically correct. I would have to recalculate the elasticity going from 7 to 6, but we'll do that on a future video. For now this is good enough to say. Okay? So what we are saying is, in the general sense, we are saying a 1% change in the price, which could be increase or decrease, causes a 0.78% change in the quantity, okay, which could be up or down. So this is the very general way of interpreting our number, okay, because that's what we got to do here at the end. We got to do our calculation, but then we have to interpret what it means. What does it mean? It means a 1% change in the price causes a 0.78% change in the quantity. And then if we put direction on it, we could say a 1% increase in price causes a 0.78% decrease in quantity. A 1% decrease in price causes a 0.78% increase in quantity. Now, the reason why this is important is because we can now make specific predictions about how the consumer will alter their behavior in response to changes in the price. So now we're putting magnitude on it. We're putting numbers on it. All right. So this has been an introduction to elasticity with Mr. Hagen. We'll talk about elasticity on a future podcast, and we'll see you on that future podcast.